Our next speaker is Dr. Richard Stevens. He's a professor in the Department of Community Medicine at the University of Connecticut Health Center, Farmington. He has identified the potential link between the disruption of the circadian rhythms by the use of electronic lights over 25 years ago. Dr. Stevens.
Well, thank you very much. It's great to be here, and I sure like this meeting already. I'm going to say a few things that you all know and that have been said before, but I want to emphasize them, and then try to get to this notion of biomarkers, because I think one of the themes of this meeting that's really quite important. And how do I change the slides? Just go like that? So okay, I'm supposed to cover overview of studies of health effects and biomarkers of circadian disruption. This is a short title. I've been struck in the 25, 30 years I've been trying to learn about circadian biology, about the evolution of this field. Once thought to be an oddity, an interesting subtopic in the larger arena of biology, and now increasingly seen as central to all biology for almost all organisms. I gather there are a few thermophiles in the vents of the deep ocean that don't seem to have clock genes, but the rest of us do, and the rest of us being everything, insects, plants, humans, what have you. And this, I guess, is not surprising, since we evolved over 3 billion years with the daily cycle of the sun. This is our benefactor, cyanobacteria, without whom life upon the planet would present difficulties for us. It's one of the model organisms for the molecular genetics of circadian biology, and I had the good pleasure of getting to know Susan Golden fairly well. Some years ago, we had a very nice conference in 2006, sponsored by the National Institute of Environmental Health Sciences. And as you probably know, there are 3 genes here. We have at least 10, but so much has been learned by examining this organism and some others. And as you know, put any of us in a dark cave with absolutely no time cues, constant food, constant temperature, and we will cycle indefinitely at 24 hours in core body temperature, sleep-wake cycle, physical activity, hunger and appetite, metabolism, and various hormone production, and expressions of clock genes. These rhythms are coordinated under natural lighting conditions. Now, links of circadian biology to physiology, and again, this has been said already, we really want to emphasize it. It's only in the last 10 to 15, maybe 20 years that this has really been emerging. And for us as the epidemiologists, we need to try to figure out how to take this knowledge to design better studies. So understanding what we mean by circadian disruption and what we mean by light, as Dr. Figueroa was pointing out, that will enable better epidemiologic studies, of course, and is awfully interesting in its own right. Circadian control, metabolism, how we process the food we eat. And I'm putting up things that are pertinent to us epidemiologist types for cancer, diabetes, other particularly chronic diseases. DNA damage response, how we are protected from radiation and toxic chemicals. Assis Sankar just received the Nobel Prize in Chemistry for his work on nucleotide excision repair, and he's been working, I think, doing wonderful work about the circadian aspects of that process. And he also was responsible for characterization of some of cryptochrome, I gather. Hormone production, of course, how we grow and develop. And this was my entree into the field in the mid-1980s. I was fascinated with the toxicology of melatonin as an anti-mammary tumor agent, extremely potent anti-tumor agent. And then, of course, cell cycle regulation, how tissues are kept functional. I had the good pleasure to get to know Paolo Sassone Corsi, who is one of those who's really been intimately involved in this area of circadian control of cell cycle checkpoint genes. And for those of us interested in cancer, that's could be very important. Now, so what about circadian disruption? And what I was struck with long ago was essentially humans, there's 2 aspects of our history, 2 epochs. There's 3 billion years, maybe 4 billion years. There's some evidence life might have started 4 billion, but at least everybody agrees on 3 billion years ago, up to about 130 years ago, in which we had 12 hours of sunlight and 12 hours of dark, season and latitude permitting. I was corrected by Neil deGrasse Tyson to say it's not 12 hours of dark and then light. There is a transition period, and I understand that. But we had that. And now, in the last 130 years, electricity, the enabler, and I have a slide that uses the term as well. Shift work, evening, of course, late night reading or TV, dimly lit bedroom, short sleep duration, and there's a lot more to that, which I really hope we will talk about more. What do we mean by sleep duration embedded within dark, physiologic dark, as opposed to 7 hours of sleep in only 7 hours of physiologic dark, and we'll get into that. Oh, and this is the definition we published, and I won't go through it because we're going to get into that. Melatonin is, again, was my entree into this arena about health and lighting. Monoamine hormone, you all know that. Robust marker of circadian rhythmicity, both an output of the SCN and a modulator of its gene expression. So it's a kind of a special molecule in many ways. SCN is rich in melatonin receptors. And electric light, the enabler. I agree about this in the sense that you have direct melatonin suppression by certain aspects of electric light in the middle of the night. But even without direct melatonin suppression, does, I think, allow for circadian misalignment, eating at the wrong times. Even if that's not enough light to suppress melatonin, electric light allows us to eat in the middle of the night. Dim light phase shifts, melatonin is lowered. Marie Dumont, very nice work. Sleep disruption from bright light in the evening and perhaps dim light during the day. And there's been a series of studies in the last 6 or 7 years taking Dr. Brainerd's essential basic work on monochromatic light and then bringing it into the kind of lighting that we all experience from our iPads, evening room light in our homes. And and part of the result of those studies is brighter light in the evening having some effect, a negative effect on sleep quality. Now, my entree into this was breast cancer. The theory is real easy to state. Electric light at night alters hormones, increasing risk, and thereby explains some of the high-risk industrialized societies. So we make a statement like this. It's very easy to say that, but how in the heck do you gather reliable evidence in human beings, as well as animal models, but in human beings? And that's what epidemiology is all about. We cannot do intervention trials of anything that might be a hazard, so it has to be observational epidemiology. We know that cigarette smoking causes lung cancer based entirely on observational epidemiology. There, of course, have never been an intervention trial. So I and a number of other people made predictions, and one of the first predictions made, in fact, the first, was shift-working women would be at higher risk of breast cancer, with the full understanding that non-shift day-working women are also exposed to electric light during the night. But this is, we felt that the shift-working women would have even more of that exposure. And there were several others. Another prediction by Robert Hahn, who is at CDC, but blind women at lower risk. He said if blind women cannot perceive light at night in a circadian sense, there actually are some who can, then they should be at lower risk of breast cancer. Another prediction, lighted bedrooms at night increase risk, and short sleep increases risk. Dr. Figueroa brought up the ecological studies. Another prediction is those communities that are more highly lighted have higher breast cancer risk than those that are not. None of these, because they're observational, is going to prove cause and effect by itself. But at some point, the way the IARC works is a panel of experts looks at the body of evidence and says, either says or says not, the only way to explain this body of evidence is cause and effect. There's no other viable explanations for this observational epidemiology. We have to take account of confounding, bias, misclassification of exposure, which is what Dr. Figueroa is talking about a lot. What do we mean by light at night? All of those things can mask a true effect should one exist, or, with the confounding, create a spurious association. So we're real well aware of those kind of limitations. Breast cancer is particularly interesting and important to me and to so many of us. Pandemic, high in the industrialized world and rising fast in the developing world. It's a major public health issue in sub-Saharan Africa. No scientific consensus on one major cause. Everybody's got a theory. There's no consensus, though. This is unlike other common cancers for which the major causes are known, such as smoking and lung cancer. 90% of lung cancer occurs in smokers. Liver cancer, the hepatitis viruses. Cervical, now we know about human papillomavirus. Stomach, H. pylori. But not for breast cancer. There is not that consensus. So, For the shift work, as has already been mentioned and everybody knows about, I guess, back in 2007 it was classified as a probable human carcinogen, a 2A. This was a Johnny sort of brought this up, 51-word sentence, required many hours to write this sentence. And it was on the basis of blah, blah, blah. The working group concluded that shift work that involves circadian disruption is probably carcinogenic to humans. Well, what's happened since then? I was asked to say what's the latest on shift work, and I'll try to say this. For a while there, I thought meta-analyses were going to save epidemiology. They were going to give us consistency, bring everything together, have order in the midst of chaos, but that ain't the way it is. Meta-analyses, even two good groups can do it and come to somewhat different, even major different conclusions based on the assumptions they make in the inclusion-exclusion criteria. In any event, these are 4 that were published, all of which had a significant elevation of risk, but a couple of them were extremely minor elevations. Okay, and then since those meta-analyses, there have been at least, I found 4 new studies, 3 of breast cancer, 1 of prostate. One was a case control study, 700 cases, 700 controls, ever, never night work. This was in sleep medicine, odds ratio of 1.34. Torborn Ackerstead in the British Medical Journal, a cohort study, 863 cases over about 8 years of follow-up. Ever, never was not, no relationship, but those who had a long period of shift work, 1.92. Papanatanaou, European Journal of Epidemiology, case control study, 1,700 cases. Ever, never was 1.18, not quite statistically significant for invasive tumors, however it was, just barely. And then the same group published on prostate cancer, and ever, never was 1.14, over 27 years of night work, 1.38. So it seems to me there are 2 possibilities for explaining these shift work studies. One is, the truth is, there's no effect. Shift workers are certainly not at higher risk of breast cancer. The small relative risks are due to bias and or residual confounding, and that has some technical meanings to epidemiologist types. But the other possibility, which I will confess I favor, I'm highly biased, but I look at this evidence and I think this, that the truth is shift work increases risk due to circadian disruption, which we're talking about and trying to get some focus on, from electric light exposure. And if so, if that's the case, then the estimated relative risks are an underestimate because day workers are also exposed, and this exposure has been said by so many people. I'm so pleased that this is finally bubbling to the top of consciousness, particularly at NIH. The public is real interested in. The media has been covering this stuff for a long time, but this is good, this kind of attention at NIH. We're all exposed, almost all. So, where are the disease connections? Cancer, breast and prostate, maybe others. Obesity, altered leptin, you've heard this already, altered leptin ghrelin, diabetes, glucose metabolism, and perhaps, and this is another bias of mine, perhaps most important of all, but very difficult to study, is affect and mood and depression. If you don't feel good about yourself or your life, nothing else really matters. And then so how many minutes I got left? I'm sorry, I lost track. 5, good. Now to the biomarker thing, and there's a paper I'm sure we're going to discuss, came out recently on a time-independent biological marker of circadian disruption. And it's in PLOS One. I don't have it in front of me to give the citation. And I was thinking about that, and we want to pursue that kind of thing, but in a way, we kind of published something on this along these lines. We didn't think of it quite that way. And that is a paper called Clock and Breast Tumorigenesis, was in Cancer Research, case control study in Connecticut. We had, in this case control study, 80 cases gave blood before any kind of chemotherapy or hormonal therapy. And our prediction was that there would be a significant difference in promoter methylation in 2 of the clock genes, clock and cryptochrome 2. And we actually focused and predicted that there would be hypomethylation of clock and hypermethylation of cryptochrome 2, the reasons for which I'm sure we'll have time to talk about. But lo and behold, we actually did see that, statistically significant. We put that in, not large and maybe not meaningful, we'll see. but it was statistically significant. Then, with Johnny Hansen, we predicted, therefore, that working women would also show hypomethylation for clock and hyper for cryptochrome 2. And it's a very small study. I'm just aching for this to be replicated by others, obviously. We put in a grant proposal and just missed the pay line to follow this up. Yang Zhu, my dear colleague at Yale. And with Johnny, we looked at shift workers and the Danish members of the diet, cancer, and health cohort who were enrolled between 1993 and 97. 19 long-term night workers, 98 day workers, all disease-free at blood draw, and also found these two things. Now, I was thinking that from the point of view of causing disease, but also these kinds of high methylation status could be biomarkers of circadian disruption. So I hope we talk about that. Then a wonderful group in Italy, Bracci and others, 56 day working nurses. This was the Scandinavian Journal of Work Environment and Health. 60 rotating nurses, morning blood taken after a day off and a nighttime sleep for all nurses, which is an important part of the study. But they found, now they didn't look at methylation status, but actually the expression of clock and cryptochrome 2, and lo and behold, they found a consistent result. Obesity and Lanvin, and with the 30 seconds I've got left, I'll just say, because I was asked to say a little bit about this, there have been 3 studies that have reported associations of light at night and obesity. They're all cross-sectional, one from Japan, one from the UK, one from Korea, all in good journals, in fact, very good journals. Light in one of them, light was actually measured in the bedroom. And this, on a cross-sectional thing, BMI was, and metabolic markers were associated with level. This is cross-sectional, a very large cohort, light level in the bedroom as reported by people, not measured. And then from Korea, this just came out last week, cross-sectional, 8,500 adults in Korea, outdoor light. And this is from the satellite images that Dr. Fugaro mentioned. So we need to talk more about, of course, that as a surrogate for circadian effective light. Thank you very much.